Hello, I'm Jerome, and today I'll be explaining the inverse functions, logarithms, and logarithmic differentiation. To start, we'll discuss inverse functions. F of x equals x to the negative 1, which is the same as 1 over x. Now the derivative of x to the negative 1, or 1 over x, is going to be the natural log of the absolute value of x. Later, to find the derivative of natural log of absolute value of x, we can use u substitution. The derivative of natural log of absolute value of u dx will equal to 1 over u times the derivative of u, which is du over dx. And this will equal out to the derivative of u over u. Now, since natural log equals the integral from 1 to x of 1 over t dt, the integral of natural log of x with respect to dx will equal to 1 over x. And x has to be greater than 0 because all forms of natural log of x must be positive and real numbers. Now you can also there's also logarithm rules, which are natural log of a times natural log of b equals out to the natural log of a plus the natural log of b, and also the natural log of a over the natural log of b equals the natural log of a minus natural log of b. The value of natural log of 1 equals out to 0. The value of natural log of 1 over b equals a negative natural log of b. The natural log of e will equal to 1. The natural log of a to the p over q equals p over q times natural log of a. Now we'll reach also the logarithmic rule. Here's the explanation to why natural log of e to the x equals x, and e to the natural log of x also equals x. According to this graph here, the graph we are shown the graph of e of x and its inverse, basically, which is natural log of x. Now, as you can see, coming through the middle is a dotted line of y equals x. This proves that, as you can see, there are basically reflections over this y. E of x and natural log of x are both reflections of each other over y equals x, which in turn proves that both of them can be inversely related and equal out to x. F of x equals y, which means the derivative f to the negative 1 of y equals f to the negative 1 of f of x, which equals out to x. F to the negative 1 of y will equal x. And that can also mean that f to the negative 1 of f of x equals x. And this is a prime property of inverse functions. Furthermore, to better understand inverse functions, logarithms, or logarithmic differentiation, we will do an example. Number 17 from 7.3 states the integral of tangent 3x dx. To solve, we already know the derivative of secant squared x is equal to tangent x. So that's how we came upon secant squared. Now, it's secant squared, you still have the 3x. And to solve, you have to do the derivative, the inverse derivative. You have to do the derivative and then find the inverse of that function. And the derivative of 3 of x is going to be 3, and the inverse of 3 is 1/3. So that's how you came upon secant squared 3x over 3 plus c. Thank you very much. This is Jerome Jingling, and this has been my brief explanation of inverse functions, logarithms, and logarithmic differentiation.